Today we are going to talk about the invisible threat, that is GNS jamming and spoofing, which is very common these days, and it's happening very frequently. And few areas such as Persian Gulf, there's a lot of jamming and spoofing happening for GNSS system. So let's now have a look, and let's try to understand what does jamming, spoofing, what is jamming, what is spoofing, and what actions we can take. So today's navigation system is very much relying too much on GNSS systems. Okay, they have got high standards of navigations for safety, ECDIS reliance, and automation. But in the same time, there is a lot of vulnerability because we are relying on a satellite which is about 20,000 kilometers in the medium Earth orbit, and when it is transmitting the signals, by the time the signal reaches the vessel, the signal becomes very weak, and it's extremely low powered, so it's not very difficult to disrupt those signals. So these are the threats which we have for GNS signal disruptions. This is a small presentation over here where we can see that these interruptions, which could be intentional, man-made, or it could be unintentional. So we are now going to see talk about the jamming first, which is the intentional. So if you see this intentional, man-made, jamming is basically intentional. When the receiver dies, basically you have no signal, so the receiver dies, he has no clue what is happening. Then the second is spoofing. Spoofing is when the receiver is lying, so basically it is getting some signals, so the GPS or the GNSS is getting some signal, but maybe the signal is not correct and you have no alarms. Then there is another category which is called me-conning. Me-conning is like a lazy rebroadcaster. In this, a person or an organization will record the GNSS signal and rebroadcast at later stages, okay, to confuse the receiver. Then there is something called AIS spoofing, whereby you can have some targets on your ECDIS which is actually not there. So these are the false targets or ghost targets. Now we will see for unintentional disruptions do happen, and these things were there from before also. This could happen because of the multipath, it's getting bounced due to a mountain, a rock, or some buildings. So you're getting two signals, one is direct and one is getting bounced back. The second could be shadowing. Shadowing is happening because when your vessel is sailing in coasts of like something like Nigeria, Indonesia, where you have got big mountains, and your vessel could be just next to a mountain and you're sailing there and you're in the shadow area, you're not receiving any signals. There could be a solar activity because of which you are having some interruptions now, and there could be some radar or TV interferences which are taking place, due to which you are receiving a signal which is disturbing your actual GPS signals. Now let's see one by one and try to understand what are the intentional signals. So the first one that we are going to talk is jamming. So in jamming, what happens is, jamming is dangerous, but in this at least the receiver will receive some alarm. When you are on the bridge, wheelhouse navigating, you will get some alarm that there is no position signal, or there is no time, or the navigation signal lost on the ECDIS. So you will be having some alarm, so you will be alerted in this. And here we can see that there is a satellite which is sending a signal. It becomes very weak here. So there is some station which is sending a radio frequency noise, thereby it is blinding the signal which is coming to the vessel, and then therefore you are blinded now and you cannot see anything. Or in other case, we can say that the receiver is dead now, he is not receiving any signal from the satellite. The second is spoofing, when the receiver is betrayed. So in this, what happens, this is also called like carry off attack. So in this happens in three stages, you can say over here. So first, The attacker will try to synchronize with the legitimate GNSS signal. So he will first try to synchronize the signal, and then in the second stage he will slowly override the signal. Okay, he will slowly override the legitimate GNSS signal, and then in the third step he will be the one who is having the control of the signal, and he can send any signal to the vessel, and then you will be receiving all the false information in your GNSS receiver. So in this, the danger is there because it is very extreme danger, because the signal perfectly mimics the real satellites and the receiver does not trigger a loss of signal or alarm. The EGDIS offset goes unrecognized, leading the bridge team into a grave peril. Okay. So this is very, very dangerous. Spoofing is very dangerous because you are not getting any alarm and your equipments will be working as normal. The third, which is meconning. So in meconning, what happens? There is GNSS time spoofing and also meconning. So in GNSS time spoofing, what happens is the cyber attack could happen on your vessel, and then he could manipulate with the time of the GNSS receiver. So this is one kind of spoofing which happens, and the other is spoofing. This is meconning. In meconning, what happens? The receiver over here, he will receive a genuine GNSS signal. He will receive it, and then he will rebroadcast it to the vessel at some other specified time, whereby the receiver on the vessel will be confused which is the actual signal. So this is the way, and this is called the lazy spoofing attacks. Simply record genuine GNSS signal and retransmits them with a delay. The impact, it confuses the receiver without requiring the attacker to crack or complex the codes. And then this is AIS spoofing. Over here we can see now there is a vessel. This is our vessel which is going, and then on the port side we see one target, but in reality you cannot see any target. So this is called AIS spoofing, whereby the attacker can force a vessel to alter the course and then proceed towards some danger, or proceed the vessel out of its track. So this is called AIS spoofing. So this is the synthesis. Now let's do what happens in jamming, spoofing and meconning. If you see the intent, jamming will block, spoofing is decisive, and meconning will confuse you. And if you see the receiver state, in jamming it is you will get an alarm, but the receiver basically dies. In spoofing, it tracks falsely, and it is basically a lie. And same way in meconning, it is a lie and you will have position jumps. These are the other kind of interference that we have seen. This is the multipath bounce. You can see there is an signal which is being reflected due to a mountain, and then you are receiving two signals. So these are non-line of sight signals. Shadowing can happen when you are off a cliff or some mountains and there is no line of sight. In this case also there can be a unintentional interference which can take place. So there are a lot of defense that we can do. So we will be talking about all the defenses that we can carry out. So the first thing is to use a multi-constellation receiver, whereby you can use multiple receivers, like we have got GPS, GLONASS, Galileo and BIDU. So if one of the system fails, you have another system which can take over. So tracking 4 global position systems simultaneously rather than relying solely on GPS. Then you can have a multi-frequency receiver. A receiver, most of the receiver which takes place as of now is in frequency L1, which is the GPS. Everybody is using GPS and we are using L1. So the jammer's first preference is to have interference in this frequency, that is L1. But if you are using another like BIDU, you have got another frequencies which it is using. So if the jammer is attacking on L1, you have another frequencies by which you will be receiving the positions. So this is an multi-frequency receiver which we can utilize. The third one is inertial measurement units. So this is an instrument which can be collaborated with your bridge instruments, whereby it has got two functions. It can also calculate the linear acceleration and the gyroscopes. So it can give you the distance and it can give you the directions, but this one is not very reliable. It can have a off track of about 1 mile in 1 hour. So yes, it is, but you can consider this thing. Inertial measurement units can be considered. It can give you positions. Then there is something called shield component, that is navigation message authentication. So there could be an authentication done, whereby when the receiver receives a signal, it will be authenticated that the receiver which we have received was sent by an authenticated satellite, and this is an authenticated signal. So this is also an procedure by which you can have some control over spoofing and jamming. So some actions to detect that there is some jamming or spoofing is to use ship's track line on ECDIS. This can be one of the first indicators of jamming and spoofing. So over here we can see that there was a track line and suddenly you have got shift of position. So this is the first signal that an observer can get on ECDIS that there is some jamming or spoofing happening. And we can also use radar overlay, which can also give us the second indications of jamming and spoofing which can take place. We will now see how to mitigate all the risks that are there and what are all actions as a seafarer we can do to avoid jamming and spoofing effects. So first thing that we can do is always monitor HDOP values. So these values are available in you can see these values on your GPS screen. Always have a look what is the HDOP values. So HDOP values will be normally ranging from 0.1 to 20. Lower the value the better. So you should always have a smaller value, and in open sea you should have an HDOP value which should not exceed 2, and if you are having an HDOP value which exceeds 5 or 6, that means it is an alarm status, there is something to bother. So these are the first thing that we should do on our GPS or GNSS signal, that is watching the HDOP. There is one more function which is 2D or 3D. So on your ECDIS we should check whether the ECDIS is on 2D or 3D. So 2D is basically two-dimensional and 3D means you are also getting the altitude. So it is latitude, longitude and altitude. So the difference between 2D and 3D is for 2D positions you need 3 satellites, and for 3D positions you need at least 4 satellites. So always if you have an option, shift to 3D and make sure that you are using 3D options. Over here we can see the mode is 3D and we have shifted to manual. So if you have got more satellites, means you have more chances of getting a more accurate position. Then this is a function called RAIM. This is receiver autonomous integrity monitoring. This is a function. What happens is whenever you are receiving any position, the GPS receiver or the receiver will automatically select the good satellites which are there in this horizon now, but it is automatically not going to consider the other satellites. But in RAIM function, when we switch on, it is going to compare with other satellites which are there in horizon, and it will compare and give you the position with relative to the satellites which are not considered, and then it will give you a position over here like this RAIM, whether it is safe, and it is also giving a difference. Say it is about 100 meters, so you will get an alarm if the difference between the positions which are good satellites and the satellites which are not so good at the horizon as of now, if the difference between those two positions is more than 100 meters, you are going to get an alarm. So it is giving you a status here safe, and it will also give you a status unsafe. So this is a function which we should switch on if you have a function in your GNSS system. And we should always use DGPS. We have always been using DGPS, so if you have an option, For DGPS, always use the DGPS. There is a function called SBAS. Okay, this is satellite based augmentation system. What happens is this works exactly like DGPS. In DGPS, there is a station which is located, which receives the GPS signal, and then it sees what is the correction between the actual position and the position received, and then it will transmit the correction by a VHF frequency to the vessels nearby. But in SBA system, what happens is the same correction is not transmitted directly to the VHF via VHF frequency, but it is transmitted back to the satellite, and then satellite will retransmit it to the vessels. So this is a function which is very similar to DGPS, but in this case the satellite will be retransmitting the corrected positions with the corrections. There is another function, signal to noise ratio. So a high SNR signifies a clear signal with minimum interference, while a low SNR suggests a weak or obstructed signal. So always make sure that you have got an high signal. So this is what we can do. Lastly, what we can do is there is an elevation mask. So this elevation mask is normally auto selected to 5 degrees. Typically the value is 5 degrees. So any elevation which is less than 5 degrees we will not be selecting, because you will be getting the disturbance or the signals normally at a low level. So this is also a selection which we can do. Now we will go and we will see in the GPS receiver what all settings we can do in actual. So this is our GPS receiver, and now we are going to see how to do the settings. So these are the settings which are here now. Okay, so now we are going to set our GPS receiver for jamming and spoofing. So in this we will go to section 6, that is GPS beacons and spars. Over here you can see we have got all the menu. We will see in section 3, set elevation mask to 5, which is recommended by the publication. So we have set our elevation mask to 5. Number 4 is HDOP value. So HDOP value less than 5 is good. If you are getting HDOP value more than 5 or 6, it's an alarm status. Now we go to section number 6. So section number 6 is RAM accuracy level. So RAM accuracy level is set to 30 in our receiver. We have already seen what is RAM. RAM means it is comparing the position from the good satellites and the satellites which are not so good. So we have set to an alarm of 30 meters. Next is our section 8, which is beacon and bus. So once you select this, so we have kept our SBS system to auto. So if there is any corrections from the satellite, so we will be receiving it on auto. So this is a receiver, this is a BiDo receiver, and in this GPS we can see that we have a fix which is now giving shown by 3D. So this is a 3D. Our HDOP value for BiDo is 0.7. For GPS it was 4 for the same location. So this receiver is giving more accurate values, and our RAM is the alarm level is set to 100, so it is still safe. Now we will see how to set our receiver. You go to the menu over here in the system settings, you go to GNSS, and we see here selection number 3, elevation mask is set to 5 degrees, which is the recommended, and it is selected to 5. Now this is the RAM. The RAM we have selected to accuracy of about 100 meters, so which is fairly good enough. So it is giving us an accuracy, and our datum is selected to WGS 84. So we have seen today how to set our GPS receivers for jamming and spoofing. It's not that we cannot do anything. Seafarers have some options we can do, and we can safeguard ourselves, vessels safely.
Đâu vậy?
너는